In section 4.1.13, we want to match the linear correlation coefficient to the scatter diagram. And the scales on the x and y axis are the same for each scatter diagram. So for the first one, we have our explanatory variable and our response variable for all three. And you can see how each particular graph isn't the same. So the correlation coefficient for part A, which is called R, is equal to 0.810. B, R is equal to 0.946. And C, R is equal to 0.523. Now, the linear correlation coefficient is a measure of the strength of a linear relationship between the two quantitative variables. If R is equal to +1, or close to +1, then there is a perfect positive linear relation between the two variables. If the value of R is closer to +1, then the stronger is the evidence of a positive association between the two variables. Now for part A, notice that the correlation coefficient R is equal to 0.810. It is less than R, which is equal to 0.946, and greater than R is equal to 0.523. Therefore, the scatter diagram that matches the correlation coefficient R is equal to 0.18 is graph 2. And the reason why is because, we have all these lines that we can form a line, but we have this one data point that's a little bit what we call sort of an outlier from all those data points. So that's why A is going to match with graph number 2. Now for B, where R is equal to 0.946, we see that it's greater than R is equal to 0.810 and also greater than 0.523. Therefore, the scatter diagram closest to a straight line matches the correlation coefficient of R is equal to 0.946, since that number is very close to 1. So therefore, this is graph 1. Part C, since R is equal to 0.523 is less than both of those first two, then the scatter diagram associated with this correlation coefficient will be more spread out than the scatter diagrams for the other two. So graph 3 matches the correlation coefficient with R is equal to 0.523.